In previous lessons, we talked about quadratics, and we learned about two special patterns of perfect squares, where we learned perfect square trinomials and we learned difference of squares. We can increase the degree from a quadratic to a fourth or sixth or an eighth or anything of an even number, and we can say that it's in quadratic form. And if it's in a quadratic form, we can then use that form to use the patterns such as perfect square trinomials and difference of squares. And so when we do that, we can break up the even numbered exponents in the same way that we broke up the exponent of 2. So it's important that we look for these opportunities to do that. So if we look at example problem 2, we'll take a look at a couple examples here. You can see that right off the bat we have a binomial, and so we remember our binomials were in terms of difference of squares. Now, what we're looking at here is 81 is a perfect square of 9, 16 is a perfect square of 4, but don't let the x to the fourth fool you. X to the fourth is also a perfect square because it can be broken up into x squared times x squared, and so x to the fourth technically counts as a perfect square as well. And so what we've got going on here is that 81x to the fourth represents as a perfect square because it breaks up into 9x squared and 9x squared. And so you can see here in this first step we are breaking up 81x to the fourth minus 16 into a difference of squares problem where we have one positive and we have one negative value. Now, this is extremely important that we end up getting one positive and one negative, because if you look at this very closely, you can see that the second binomial is also another difference of squares. Okay, and so we told you in the prior video that you will need to be looking out for a second level of factoring possibly, or maybe even a third level of factoring, and that's happening right here. So if we take the first one, we break up the difference of squares, we end up with another level of difference of squares, and so we then break that up as well. And then keep in mind 9x squared plus 4, we do not have a sum of squares. We learned a sum of cubes, but we do not have a sum of squares. So the final answer would be left that way. Okay. Now if we look at part B, we are dealing with a degree of 6. But when we're looking at factoring, remember, first thing we should look for are those values or variables that are common monomials that can be factored out. And in this case, you can factor out not only an x squared, but you can also factor out a 4. Now, the second part, x fourth minus 5x squared plus 6, is not necessarily a perfect square on either side, but it is factorable just like a quadratic expression is. So all we have to do is take the x to the fourth and break it up into x squared and x squared, and break up the 6 into its two factors as well. And so this follows what we call the quadratic form, and you can see that we get x squared minus 2 and x squared minus 3. So this is just like factoring from chapter 5 from our quadratic section. So see if you can use those factoring skills that you learned in chapter 5 to work on sample problem number 2, part A and B at this point. Okay, so if we look at sample problem number 2, part A, we can see here that we're dealing with a binomial that is being subtracted. So this is going to be in the form of a difference of squares. Now, if you recall, difference of squares, we break up the first and the second term into their perfect squares. Even though we have an x to the fourth value, the x to the fourth value is still broken up into a perfect square. So x squared times x squared. So we're going to do that. And I know that I'm going to have two binomials here. And so the first one's going to break up into 5x squared and 5x squared. And the second term is going to break up into 6 and 6. And remember, difference of squares has different signs, so one positive and one negative. Now, at this point, it would be wise of you to ask yourself, are there any more parts that I can factor? So you look at 5x squared plus 6. That's a binomial, and it's not a cube, it's a square, so we can't factor that out. But we look at the second part, 5x squared minus 6. We have to ask ourselves, are we dealing with perfect squares here? And as you can see, 5 is not a perfect square and 6 is not a perfect square. So we're in a situation here where we cannot factor any farther, and so we would just stop at this point. Okay? Alright, let's take a look at part B. In part B, we're now dealing with two variables in the same problem, an A and a B, and so sometimes this can be a little bit confusing, but we're just going to take it one step at a time here and see what we've got in common. And if you look at this, we've got a B value, B variable, in each of the terms, and so we can factor out actually a B squared. So I'm going to take out B squared first, and that's going to leave me with an A squared minus 8A and 1B plus 16B squared. Now, we're looking at a situation where we have a perfect square trinomial. We have a perfect square with A squared. We have a perfect square with 16 and B squared. So those can be broken up into those two individual parts. So I'm going to say A, and of course this is 4B and 4B, so we're just going to break up each individual part. And if you recall, in a perfect square trinomial, the signs for the two binomials are always what that middle sign is, or that middle term. So we're going to have a negative and negative. And if you recall from solving quadratics, we have two binomials that are the same, so we should write that as a binomial squared. So we've now factored this particular problem, and we had two different levels of factoring. We had to factor out a common monomial first, and then we had to look for the second level of factoring with a perfect square trinomial. Alright, very good.